Okay, so today we're doing ratios, conversions, and rates. But before that, I'll go over the homework problems from last class, which was on slope. And yeah, so these are all the answers on the screen. And I'll go back to the answers obviously later and while I'm explaining. But if anyone had any questions that they didn't know how to do or like were unsure of, then here are like the answers so that you can check your work um with. So yeah, I'll just like stay here for like maybe 30 seconds so you guys can go check your work. And then after that, I'll explain the problem. But yeah, these are all the answers to all the homework, and hopefully they make sense and you guys could do them. And if you couldn't, that's totally fine. I'm gonna go over and explain how to do them. Okay, so I'm gonna go to the homework problems and explain these answers. But in order for me to do that, I need to like show the homework as well. So this is the homework. If we look at the first problem, it says to identify the slope and the y-intercept. So the way to do that is we have y equals negative 1/3 x plus 6. And we know that the slope is the coefficient of x. So that would mean the slope is negative 1/3. And the y-intercept is going to be 6, which is also shown over here. Because the y-intercept is the thing that you add at the end, and then the slope is the coefficient of x. So then for the second problem, it says write the equation of a line with slope negative 5/2 and y-intercept 4. So this is just written as y equals negative 5/2x plus 4, because again, slope is the coefficient of x, and the y-intercept, you just add that on at the end. So that's the answer to problem 2. For problem 3, it says write the equation through the line negative 6, negative 2, 0, 10. So how you want to do this is that we want to first find what the slope is, and we can tell that the y-intercept is 10 because this point is 0, 10, so when x equals 0, y equals 10, and that's the definition of the y-intercept, right, when x equals 0. So we already know that the y-intercept is 10. So for this one, we only really need to find the slope. And we can basically just find the slope as doing the change in y over the change in x. So I did negative 2 minus 10 over negative 6 minus 0. So that is basically just 2. If we divide negative 12 over negative 6 is 2. So the slope is 2 and the y-intercept is 10. So that's how we end up getting y equals 2x. And then for question 4 and 5, it's just given these lines, you find the slope, and how we do that is we do change in y over change in x, rise over run. So for this one, 10 minus 1, 9 over 3, so slope is 3. And then for this one, I did negative 5 minus 7, negative 12, divided by 9 minus negative 3, which is 12, negative 12 divided by 12, is negative 1. So that's how we got the answer of slope is 3 and slope is negative 1 for questions 5 and 6. Those ones you kind of just plug into the slope equation. Not too much thinking through. Okay, then question 6. The bottom 3 are like more word application problems. So for like 6, for example, a cell phone company charges $10 a month plus 5 cents per extra tax. So write the cost equation. And basically you can say that the $10 is like the y-intercept, and then the $0.5 per tax is like the slope. Because when you increase by 1 tax, the price increases by 0.05, right? So then the cost, which is y, equals 0.05 plus 10. So it's kind of just interpreting, and we can do the same thing for 7, right? If a babysitter charges $20 flat, that means like no matter what you do, you would still have to pay $20. So $20 would be the y-intercept, and then $12 an hour. So 12 is the slope, and then you get the equation y equals 12x plus 20. And then the bottom one is kind of the same thing, except for we can see that $20,000 is the y-intercept, but it loses $25,000. So you have to subtract $25,000. So yeah, that's why the slope is negative $2,500. And yeah, so that's how we get y equals negative 2,500 x plus 20,000. Does anyone have any questions about the homework? I feel like they didn't understand. Okay, since no one has like spoken up, then I'm going to assume not. But if you do, you can always like email me or just ask me to the classroom. So yeah. But anyways, we're gonna move on to like ratios and stuff today. So basically, just to like introduce the concept, ratios and conversions are used kind of a lot in real life, and so are rates. Like ratios are used a lot in like cooking, right? If we have like sugar and butter, and we're trying to see, well, like how much to add, ratios are used a lot. Or even like in classrooms, right? Like what percent of the class, what is the ratio of boys to girls in a class? Like that's very common. And then ingredient scaling is similar to cooking. And then conversions are used a lot when we're using measurements. Like for example, if we're driving somewhere, someone might say, oh, this place is like 20 kilometers away. But you might know miles, so you're like, oh, how many miles is that? Or if we're measuring like gallons of water, someone might use liters instead. So you need ratios to convert from liters to gallons. Or even time units, like seconds to hours or hours to days, or like hours to minutes. All this stuff is all converted using ratios. And then rates, common, speed, density, and a lot of like price per unit. So like if something costs $2, right? So these are like kind of the real life usages of everything that we do. And they're very applicable. I think this probably is going to be a thing that, is most commonly used out of everything that we talked about or we talk about. So, yeah. So let's start off with like definitions. We'll start off with ratios. So what is a ratio? Well, a ratio is a comparison of two quantities by division. So there are different ways of writing this, and I'll give you an example of it, obviously. But if we have two numbers, right? It says two quantities or two numbers by division. So if we have two numbers, for example, A and B, you can say that a ratio is A to B, that is a ratio, or A semicolon B, that's also a ratio. And then you can also do A divided by B as fraction form. And yeah, a ratio that compares two quantities with different units shows how one quantity changes. That's very true. And we'll actually use that, I think, more in next class because we're spending 2 classes on this. But yeah, that is something very useful to know. So kind of like an example of this, I said in the beginning that, a classroom setting is very common for using ratios. An example of this is like, let's just say you have a class, right? And there's 12 boys in that class and 18 girls in that class. Something very common to use is like, well, what is the ratio of boys to girls, right? Well, since there's 12 boys and 18 girls, that's our two quantities, our two numbers. So then you do 12 to 18. I like to write it with a semicolon just because I think it looks nicer. Because a lot of fraction form we use division, and also when we start comparing, we'll also use division. So I think this is easier. And then you can simplify 12 to 18 to 2 to 3, and I'll obviously go over simplification a bit later, but that's kind of like conceptual. Or like if you have ingredients, right, like we said earlier. Let's just say I'm making chocolate chip cookies, right? And, the ratio of flours to sugars, I need 2 cups of flour and 1 cup of sugar. So that would mean that the ratio of flour to sugar is 2 to 1. Kind of basic definition of any ratios. Does anyone have any questions about this? Okay, again, if anyone has any questions, you can just stop me at any time. But that's like a very basic definition of ratios. So then this is like equivalence or simplifying ratios. So many ratios are like similar to each other, right? Like you can simplify them. So how do we simplify them? Well, you factor it out. This is kind of similar to like using fractions like we've done before. In fact, it's basically the same thing because another way of representing a ratio is a fraction. But using like an example, right? If we have the ratio 8 to 12, well, we can simplify it by dividing both numbers by 4 to get 2 to 3, right? Because 8 equals 2 times 4, and 12 equals 3 times 4. So we can simplify 8 to 12 to 2 to 3. Or you can scale it upwards, right? Like let's just say we have the ratio 5 to 7. But if we multiply both of them by 2, then we can get the ratio 10 to 4. And these ratios are equal to each other, but the numbers are different. So ratios are like fractions. You might want to simplify or scale as needed. And I guess like you might ask like, why would you need to simplify them? Well, in some cases, right? Like if we have 8 to 12, for example, and you're trying to like see if we have like 8 boys to 12 girls, then we could be like, what's the percent of like boys to girls? And then it just be 2 to 3. Or for like scaling, for example, like I think the easiest way of explaining this is if you're like baking something and like 1 batch of cookies, you need 5 bags of flour and 7 like cups of sugar. Well, if we're making 2 batches, how much? So then you multiply that. So the bottom 2 are questions, and I want you guys to do them, and then we'll just quickly talk them over. But simplify 15 to 20, and I guess also simplify 18 to 12. And yeah, raise your hand when you have an answer and you want to explain how you got the answer. I'll have one person explain each of them. But yeah, simplify 15 to 20 and express 18 to 12 as simplest ratio. And when answering, like, don't just say what it is. Tell me, like, what the factor is as well. Yeah. But yeah, I'll give you guys, like, a second to do the problems. And then raise your hand. And just look at them and then do them. I think a good amount of you guys have like solved the problems. I'll just call on you guys in the order that you raised your hands on my screen at least, and there will also be more problems. So if you want to explain, like there will be more problems, and I'll just call on whoever hasn't spoken then. But yeah, I think most people have had a chance to answer. So Mika, would you like to explain the first one?
Yeah, sure. So, 15 to 20 simplified is 3 to 4. Because 15 divided by 5 equals 3, and 20 divided by 5 equals 4. And that's how I got 3 to 4.
Okay, perfect. That's really good. And then Sophia, do you want to explain the second one?
Yeah. So I got so first you have to find the factors of 18 to 12 and find the greatest common factor, which is 3, and then that will equal 6 to 4, and then you divide that by 2, which equals 3 to 2.
Yeah, perfect. Okay, those are really good answers. So yeah, basically for the answers are going to be 3 to 4 and 3 to 2. And for all of these, you want to find the common factors, like both of them said, and then divide both numbers by that so that you get the answer. And that's basically how you simplify all types of um, ratios, and that's really helpful to use. So yeah, like okay. I don't know why that says okay, the title is wrong, but regardless, like this is kind of just another example of where you're having like an in class, like if you're using classroom, right? And this is an example problem. If we have like 12 boys and 18 girls, right? Like we just said before. We want to find these ratios boys to girls or girls to total. And I know some of you guys have already done this, but this is kind of a step-to-step analysis of how to do this, right? So the first thing you want to do is you want to identify the quantities, right? If you have 12 boys, right, you have 18 girls, you can write these out. But then, the total is students, right? So then we have 12 plus 18, which equals 30 total students, correct? So these are all things that we want to keep in mind. So we want to look at what we're comparing. So the first question is boys to girls. Well, that's 12 to 18. The second question is girls to total. So that's 18 to 30. And then after that, we simplify by finding common factors. So again, 6 was our common factor for both. So for boys to girls, we'd get 2 to 3, like we said before. And then for girls to total, you'd get 18 to 30, which is just 3 times 6 to 5 times 6, which just equals 3 to 5. And like the thing that I want to emphasize here is that it's very important. Like, I'm sure we all know how to find the boys to girls ratio because the numbers are kind of just there. But the thing that's kind of important about like girls to total, for example, is if we want to go back to like the when we're doing fractions, it's really important to know this because if someone asks you, like, what's the percent of girls in your class, for example, right? Then it's good to know that you want to find first the ratio of the girls to total. So you get 3 to 5, and then you can find the percent, which is just you can scale this ratio up to 6 to 10, right? You multiply both numbers by 2. Um, so then you end up getting 6 to 10, and that's just 60%, which is something that's really important for like percents, for example. But you can also do the same thing like for boys to total, but it's along these similar lines, so I'm not going to be repetitive for that. So then we'll go to proportions. It's kind of short, but like proportions is kind of just like setting two ratios equal. So a lot of, I guess, things online or like will say, okay, well, this is like A over B equals C over D. And A, B, C, and D are just like integer numbers. And you use proportions a lot when you're trying to solve for like a missing value. So if we look on the slide to the right, we have like 3 over 5 equals x over 15. That's an example of where you want to use proportions to solve for this missing value x. Um, and it's setting the two ratios 3 to 5 and x to 15 equals. And we'll learn how to solve it, but if anyone's curious, the answer is 9, just to check your work. But it's basically just using ratios from what we just learned, setting them equal, and most of the times the problem is, okay, well, if we set these equal, then what is the value? Because we're typically missing a value. So like solving proportions, this is kind of an example of it. So if we have like single like one ratio, right? Or like I guess two ratios. 3 apples cost $6, so your goal is to find how much do 7 apples cost. Well, in this case, we have the ratio. We want to identify what the two ratios are. That's the first step. We can see that the first ratio is 3 to 6, right? 3 apples, $6. Very easy ratio. Now we're trying to find how much do 7 apples cost. This will go into like the equation solving thing that we learned. But how we want to approach this is that we have 7 apples, so we don't know how much it costs. We can use a variable like x to say, okay, well, it costs x dollars. So how do we set these two equal? Well, if the first ratio is 3 apples to $6. So if we look at the units, we can say, okay, apples to dollars. Apples is in the numerator, dollars is in the denominator. So we can do the same thing for the right side. We have 7 apples, so we know this can be the numerator over x dollars because we want to have the units match up, or else they can't be equal. And then after that, it's kind of just solving an equation. So how I did this one was I multiplied x to both sides. So I would get 3 over 6 times x equals 7, and then divide both sides by 3 over 6. So you get x equals 7 times 6 over 3, which is just 7 times 2. So 7 apples cost $14. But that's like if you're just comparing two ratios. Sometimes you can be comparing like 3 ratios or 4, like 3 things or 4 things, right? And that's also a ratio. For example, like if we look at this one in a recipe, the ratio is flour to sugar to butter, right? Is 2 to 1 to 1. So let's just say like 2 cups of flours. I make chocolate chip cookies. I need, for every 2 cups of flours, I need 1 cup of sugar and 1 cup of butter. So if I want to like make 12 batches of cookies, for example, right? Like I want to make 12 cookies, a lot of cookies. I would multiply all of the numbers by 12, all 3 numbers. So then I do 2 times 12 to 1 times 12 to 1 times 12, which is just 24 to 12 to 12. So I would need 24 units, or I guess we can use cups for this case, 24 units of flour, 24 units of sugar, and 24 units of butter. So that's how you do it, like if we have like 3 or more different numbers. And you can always solve that way as well, but kind of how it works. So that's what proportions are. And yeah, proportions are mostly just used for problem solving, like finding a number. Ratios are more of your typical like fraction thing, which is these. Okay, so then I'm gonna start talking about unit conversions, which like I know we're definitely familiar with some of this, but probably not all of it. So the first question is like, why do we need them? Well, they're used a lot in science, engineering, and even in like everyday life. Now, comparing different units can make it easier to measure certain things. So the steps for this is you want to write factors as like either like a fraction or a ratio, I guess. And then cancel the units like algebra. And this can be called dimensional analysis. So if you see that term, which it may seem fancy, it's not really fancy. It's just like converting units. So like one way of unit conversion, right, is if we're looking at inches to centimeters. Well, 1 inch equals 2.54 centimeters approximately. So you can write out this as like a ratio. The ratio is just 1 to 2.54. That's inches to centimeters. So another way we do this is a lot is like from inches to feet, right? If 1 feet is 12 inches, then what is 5 feet in inches? Like, what if I'm 5 feet tall? How many inches tall am I? So then this is like we kind of use ratios in this case. So 1 to 12 is the ratio feet to inches. Since we have 5 feet, then you could do 1 over 12 equals 5 over some number of inches. And then you can multiply that over. So 5 times 1 feet would just equal 5 times 12 inches. And that equals 60 inches. So this is like very common unit conversions, or I guess also called dimensional analysis. But sometimes we have like multi-step conversions. So like when your parents are driving on the road, for an example, we have this thing called speed. Speed is typically measured in miles per hour. If you ever seen your parents drive, ask them like, oh, what speed are you going at? Well, it's typically measured in miles per hour. Most people don't say like how many meters per second you're going at, but that is another way to measure speed. So if someone was really curious and they want to convert 60 miles an hour, miles per hour is like 60 miles to 1 hour, to like how many meters, how many seconds, like what is that? Oh, okay, well that's not even right. Sorry, I don't know why my computer is but yeah, if you're like measuring in, sorry, like miles per hour to meters per second, like 60 miles, we can convert this to 96,560.64 meters. You can just Google the conversion because I'm not really sure what that is. But then we can also do like 1 hour is 3,600 seconds, because like 1 hour is 60 minutes. 60 minutes is, well, 1 minute is 60 seconds. So that's how you get 3,600. And then for 60 miles per 1 hour, 60 miles is 96,560.64 meters. So that's the numerator, and then the denominator is now 3,600 seconds. So it's 560.64 meters divided by 3,600 meters per second is the way you write that out. Does anyone have questions about unit conversion? Okay, I assume not. But they're commonly used. Like I think the most that you're probably gonna do is like the common ones are like inches to feet, or like time conversions, like seconds to minutes to hours. It's not very fun converting from like inches to centimeters or miles to meters, because they're just different like units. Like in America, people typically use like miles and inches and feet. But if you go to like Europe or something, meters are used a lot more, centimeters. Those are used a lot more. So I guess that's maybe like if you're traveling countries, it's useful to know that. Okay, so after all of that, these are just some practice problems and we'll go over them. But yeah, so for the practice problems, I'll just read them out loud. For the first one is like, if, let's just say someone's taking medicine, right? If the dosage of a medicine is 2 milligrams for each like kilogram in the patient, and a patient weighs 70 kilograms, how much medication would they take? And for the second problem, like if hypothetically, like if you're looking at a map, for example, if 1 inch represents 5 miles on the map, then how far is 3.2 inches on the map? And then like the last two in conversion, so like convert 2 hours into seconds and convert 3 gallons into liters. You can search up the gallon to liter conversion, like, because I'm sure you guys are like on your computer or like laptop or something. So you can search that conversion up. because that's just like a simple conversion. But yeah, these are just some practice problems. Raise your hand if you have your answer and you want to share. And yeah, we can discuss the questions. Once, I guess like over half the people have done it, then we'll probably discuss. Also, if it helps for the last problem, and if you don't want to search up, like, you know, the conversion, I can just say that one, I think 1 gallon is like the ratio is like 3.7, yeah, 785. No, but yeah, so about 785, yeah, 785 liters. So if that helps, instead of just searching it up, that's something that you could do. And yeah, I'll try to wait for most people to finish before going over them so people can compare answers and they can go through their own thought process. But yeah, raise your hand if you want to speak, and I'll call on people who haven't spoken yet first. And if we don't have people left, then I'll go with the people who've already spoken. We aren't doing Kahoot today, but next class I think we should have time for a Kahoot. Because next class we'll just go through rates, and then we can do review problems, and I think review problems are funner if we do Kahoots. So yeah. Okay, I'll give everyone like maybe like 1 more minute or 2 more minutes to do the problems. And it's okay if you can't finish it in time. But I do want to go for the answers. So yeah, maybe at like 8:38 we'll regroup and we can
I got the first two already.
okay, that's good. Yeah, I can wait a couple more minutes so that if you guys want to do the other problems, we can do them. Okay, so I think we're just going to have people answer the problem. So I'm just gonna call people who haven't spoken. Darlena, would you want to answer a problem? And just choose whatever problem you want to answer.
Can I answer the first problem?
Yeah.
So the answer that I got is 140 mg because I did 70 times 2.
Okay, yeah, good job. So yeah, that's the correct answer. So the two ratios that you want to use is 2 mg for 1 kg, so 2 to 1. And then you have that equals um, something, so x over 70 kg, and you multiply it, so then you get 2 times 70, which is 140. So good job. Kanisha, would you want to answer a question?
Could I do the convert 2 hours into seconds?
Yeah.
So 1 hour 60 minutes, and there's 60 seconds in 1 minute. So that's 3,600 seconds in an hour, and you multiply that by 2, and you get 7,200 seconds in 2 hours.
Yep, good job. Perfect. Okay. Shruti, do you want to answer a question?
I'm pretty sure 3.2 inches on the map is 16 miles.
Yeah, okay, good job. So, yeah, how you would want to do this is, again, this is like we have a proportion or comparing two ratios. So 1 inch to 5 miles, so 1 to 5 equals 3.2 to some number x. And then we can just find out that x equals 3.2 times 5, which I believe that should be right. Sorry, my computer is frozen. Okay, yeah. So then, does anyone want to answer the last problem? Let me. Sorry, my Zoom is kind of frozen right now. I'm not sure what's wrong with it. But I think some of Mika, I had you as one of the people. Do you want to explain the last problem?
Yeah, so 3 gallons into liters is 11.355 liters because since 1 gallon is 3.785 liters, I just multiplied 3 by 3.785 and I got 11.355 liters.
Yeah, okay, perfect. I also got that answer. So yeah, good job. These are all the right answers, and you guys did a really good job comparing them. So in that case, I'm going to just quickly summarize. Like I said, today's class is a bit on the shorter side because there's 2 parts to ratios and stuff. So a little short, but that hopefully means just homework will be shorter. And we can do a Kahoot next time because we'll have more time. But yeah, okay, so the review is we can say ratios are a comparison between kind of 2 quantities, like A colon B or A to B or as fractions. And then ratios can be simplified or scaled up. Like we talked about, equivalent ratios represent the same like or similar relationships, I guess. And then proportions are equations stating that 2 ratios are equal. So for example, 8 over b equals c over d and can be used to solve for unknowns. And conversions will allow you to change units using conversion factors. And just like always look at the units to make sure that they make sense and track these units. And when you cancel units, cancel them carefully. Then dimensional analysis helps ensure that units are consistent and results make sense in real world applications. So it's also kind of just comparing between units. And yeah, that's all we have for today. So Thank you so much. And if you have any questions, you can just stay behind to ask. But yeah, I will always be happy to help as well. So that's all I have for today. And my computer's kind of on camp, so we'll figure this out. Yeah, that's all. So thank you. Bye bye.
Bye, thank you.
Thank you.
Bye. Thank you.
Thank you. Bye.
Thank you.
I'm gonna
Thank you.